endless scrolling through clinical, brightly lit PDFs creates cognitive friction. To actually retain complex information, we often need to shatter that sterile block of digital text into something our brains can physically map. Authentic, hand-drawn study artifacts bypass this digital fatigue. The warmth, texture, and physical boundaries of a real paper notebook provide the spatial anchors that help lock in complex topics. The problem is speed. Modern students process massive volumes of slide decks and textbooks every single week. Writing out highly structured analog notes by hand is simply too slow to keep up with the data flow. The Handwritten Notes Study Agent repository addresses this exact bottleneck. It is built to programmatically bridge the gap between heavy digital documents and tactile, retention-optimized study materials. The system uses a strictly constrained LLM agent to orchestrate the translation of unstructured raw text into procedural, vector-based analog replicas. This flowchart maps out the full-stack ecosystem driving the project. It relies on three primary engines: an Express and Node.js backend, the Gemini API, and a Vite and React frontend. The data flow triggers the moment a dense document enters the ingestion layer on the backend server. The Express server catches this raw file, extracts the text, compresses it, and routes the heavily filtered payload outward to the Gemini LLM. Gemini structures that data into a rigid JSON lattice, which flows back down to the React frontend, where it expands into physical UI elements on the screen. Achieving a genuinely authentic visual output relies entirely on this separation of concerns. The backend parses the data, the AI acts as a spatial planner, and the frontend handles the procedural rendering. The pipeline starts at the post/API/parse file endpoint. This is where the server receives the raw binary of an uploaded file. We are looking at a visualization of raw character data. The application uses the Office Parser library as a sandbox to blindly extract all of this unstructured text from complex formats like .docx or PDF files. Sending massive text dumps directly to an AI hits context window bottlenecks as raw extractions chew through token limits. To counter this, a local token condenser scans the cluster for inefficiencies, aggressively stripping out redundant whitespace, layout junk, and non-semantic characters. This process shrinks the overall payload size drastically before a single byte of data ever leaves the local server. Scrubbing the document locally ensures fast API response times and prevents context overflow when the data finally reaches the generative AI phase. Once condensed, the payload is pushed to the post/API/generate notes endpoint. Here, the server utilizes the Google Gen AI client to route the text directly into the Gemini 3.5 Flash model. Typical LLM outputs are conversational and flat. They produce long streams of text. A React UI, however, requires precise spatial coordination. To solve this mapping problem, prompt constraints on the left force Gemini into an Agentic Stylist Planner. On the right, the AI abandons conversational text for a highly nested JSON structure, mapping topics into key value pairs for section titles, math equations, and diagram coordinate maps. The prompt also enforces a strict volume limit, requiring the AI to format the exact amount of content needed to fill 2 initial notebook pages. Constraining the LLM into a rigid JSON schema is the critical engineering step that turns a conversational AI into a deterministic backend engine for UI components. The structured JSON payload is then returned to the Vite and React frontend. The frontend avoids using heavy, static image files to simulate paper. Instead, it relies on procedural CSS and scalable vector math. This animated sequence shows CSS grid in action. It calculates precise spatial divisions across a blank plane in real time, solidifying the layout before applying the visual styling of classic notebook margins. This mathematical approach generates distinct aesthetic layouts on the fly, ranging from tightly ruled engineering graph grids to spacious dotted bullet journal arrays. Once the paper is rendered, modular SVG binding components, like steel rings or heavy leather stitching, are dynamically anchored to the calculated margins. Using procedural math to generate the physical canvas allows for infinite scaling and crisp resolution that pre-rendered static textures cannot support. To populate this canvas, the Handwriting Builder React component simulates personalized, tactile analog ink. Here, raw X and Y coordinates plot across a grid, scraped directly from an HTML5 canvas as a user draws, directly rendering these results in jagged lines. To fix this, SVG path interpolation algorithms calculate the gaps, translating erratic points into smooth vector strokes. Modular ink rules are then applied to these paths, allowing the text to render in specific styles, like thick fountain pen ink or mistake red ballpoint. The visual elements are handled by a separate engine, Sketch Diagram, which reads the diagram maps provided by the Gemini JSON schema to build visual aids. Take a look at these rigid vector circles. If they remain geometrically perfect, they look clinical. To solve this, the engine applies an algorithmic fuzziness to the geometry, warping the edges slightly to mimic the natural imperfections of human drawing. By abstracting complex vector math and path interpolation behind modular React components, the system creates a high-fidelity analog aesthetic without relying on massive asset libraries. Zooming out from the rendering layer, we see the fully populated two-page visual output. The user can then trigger the post/API/critique notes endpoint, initiating a final recursive loop. The application sends the newly synthesized notebook data back to Gemini, tasking the LLM with acting as an academic critic. The model analyzes the work and outputs an interactive academic panel. This contains a step-by-step thinking trace, concrete improvement logs, and a final graded evaluation. This evaluative layer transforms the synthesized output into a responsive, interactive pedagogical tool. The final endpoint, post/API generate next pages, introduces state management logic to the workflow. Because the system tracks the current page count context, it can continuously ingest the original document and seamlessly append consecutive pages of material indefinitely. The pipeline moves from raw ingested text through a local token condenser, relies on Gemini for JSON structural mapping, and outputs procedural React SVGs. It utilizes a modern web stack to deliberately engineer away the sterility of modern digital environments. By reverse engineering the irregularities of the physical world through highly structured code, developers can build tools that actually align with and maximize human cognitive retention.